This video tutorial is designed to help you understand how to use Etoys as a model building tool to understand patterns in earth and sky. Etoys is a programming language that's appropriate for students in grades 2nd through 12th. It's free and downloadable from etoysillinois.org. If you go to this website and scroll to the bottom and select Download and Install Etoys, you will find that there are 3 choices, one for Windows, one for Mac, and what's called Etoys to Go. Etoys to Go is appropriate if you are working in a large district and there is a large number of steps to go through to get software installed on any computer lab or laptop. What you do is load Etoys to Go onto a flash drive, and then each student can be handed a flash drive, and that can go right into their computer that they're using, and they can use it at any time. So as you can see, I have downloaded Mac installer already. It's down here on my toolbar, and when I click on that, you'll see I open up Etoys and I have a couple choices. I'm going to make a project here. So I'm going to click on Make a Project, and you'll see that as you mouse over each of these objects, it will tell you what they do. And in this case, we started our 5th grade students off with a question, and we asked them if they were on the playground, where would they see the sun rise and where would they see the sun set? They had a variety of responses to that question, so we asked them to make some observations for a day and come back the next morning, share what they found. So they were able to test out their ideas, and they came back and reported that the sun rose in the east and set in the west. So then we said, well, let me show you a program that can help you draw your observations and then animate your observations so that we can model how this happens, why the sun rises in the east and sets in the west. And to do that, we started them off with the paint tool. So we're going to make a painting. You'll see our painting tools come right up, and we challenge them to draw a sun and themselves. So I'm going to start off with a sun. I'm going to make it a circle. I'm going to choose a circle here, and I can just plop that down anywhere here. So I've got my sun. I'll go up and choose my paintbrush, change my color around, and maybe not quite that thick. Add a little detail to my sun, and I'm going to keep that drawing. I'm going to do a second drawing. This time around I want to do my person, and I'm going to add a head, and that's pretty thick, so I'm going to toss that, and I'm going to try a little thinner. And I meant to keep that as black, so we're going to try. I'm going to go ahead and right click on that, and I can delete that. I'll try one more time to get it black. And here's my head. Okay, now if I want to draw some body parts, give myself some legs, arms. I suppose I could have some hair. And I actually don't know that I want that to be straight, so I'll get out of here, close this up, just do it straight. Now I can have a little bit of curve to that. And maybe I want to do some polka dots on my dress. And how about some shoes? And I want to show where the ground is. diagram. So now that students had their object and their sun, they noticed that they could move around each of these. And so we challenged them to create drawings at sunrise, noon, and sunset. So here's an example of sunrise. One of the things that we noticed is some students put sunrise here, some students put it here. So we problem solved with them. How could we show which direction is east and west? Some students chose to do a compass rose. Some students chose to draw in landmarks, such as mountains. In which the sun would rise, so we would know where we are in the playground. Any of those worked. You can also add in text. If you go up here to your supplies box, click on text, and we could say that this is sunrise. Now, the next question we asked students was if we wanted to make our model actually move like you observe it in the actual environment. So we showed them that you can actually program the objects to do that. So if you right-click on the sun or any object that you've created, you'll find a whole series of icons. This changes the size, the color. What we're most interested in is to be able to program that sun. So when you open that halo, you'll see that we now have all these programming tiles. We're going to name this sun. And if you notice over here, if I click on this exclamation point, the sun will now turn. If I click forward, the sun will move forward. If I click sound and make a sound, it will make a croaking sound. Now, if we actually want to create the program, we can actually pull that programming tile out here, and we now have the beginning of a script. And we're going to say sun move. And if I click on that rotating, and again, the problem is this. Well, the sun actually does rotate. We just can't see using our own eyesight. What we really want to do is get this motion of what we see observing across the sky. So we challenge students to figure out ways to get that to happen. This one they won't discover by themselves. So what you have to find is that there is a rotational center on the sun that needs to be moved to the rotational center of the observer. And I did that by simply selecting the Shift key, holding it down and dragging that rotation center. And now what happens is I click this, it's rotating just as we might observe it in the sky. But it's not rotating east to west. So then we challenge the students to play around with the numbers to see what happens. And what they found is that if you program a -5, you get the behavior of the sun rising and setting. And if you do what's called ticking, you will get that movement to be constant. And we now have the sun rise and the sun set. I'm going to go ahead and pause that. And the students have created their first program using Etoys. Now we had them compare and contrast their model with the actual events and gave them some styrofoam balls and began modeling this in small groups. And most of the students were already aware that it's not the sun that's orbiting the Earth, but it's the Earth that's orbiting the sun. So our model is still, while it does model what we observe, it's not scientifically accurate. So how do we do that? And students came to realize that they need to learn how to program themselves on the Earth, and that Earth orbiting the sun and rotating on its axis. So this video will not show you how to do that. Rather, what we did is we went into, because of time, we went into the Etoys library collections, and you'll see there are over 1,700 projects. You can choose them: math, social studies, language arts. We went into astronomy and chose one that was like, there it is. If you click on that, you can download this Etoy, save it, and then you'll be able to view it. So I went ahead and already did that. And you'll see I have downloaded 2 programs. One is the one we shared with students. And now they can see they have a person on here, and the Earth is orbiting the Sun, rotating on its axis. Another way to look at this, here's another project. Here's, go ahead and see the Moon orbiting a spinning Earth, and the Earth slowly but surely will rotate around the Sun. And that is the Etoys programming model. There we go. Got the Sun. And one of the things that is helpful to show students is the math behind the program. So I'm going to go ahead and pause this Sun, open up its programming tiles. If you notice over here you have a graphing coordinates, and so a Common Core for 5th grade, students learn X and Y axes in the first quadrant. And so students can see as they increase, the X moves to the right, as they decrease, the X moves to the left. As they increase the Y, it moves up, and as they decrease the Y, it moves down. And if we were to put in coordinates of 0 and 0, you would find that the center of this first quadrant is right here. So put in a 0 and a 0, and you'll find the Sun's axis, this we now know is the center of the first quadrant. And that is using Etoys.